Hello, my name is Michelle, and I'm going to take you guys through how to interpret partial eta squared versus Cohen's d. So first, we have to define effect size. So effect size is going to be defined as the statistical concept that measures the strength of the relationship between two variables on a numeric scale. So for example, if we wanted to look at the height of men versus women, you would notice that on average, men are going to be taller than women. And that difference between the height is going to be effect size. The greater the effect size, the greater the difference. And statistically, it's going to help us determine if the difference is real or if it's due to a change in factors. And there are many types of effect sizes that we can use in statistics. One of them is Cohen's d. Cohen's d is going to be measured as a measure of effect size based on the difference between two means. So Cohen's d, for example, tells us if it's a d of 1, it means one means of the difference, sample mean, it's going to be 1 standard deviation. 2, it's going to be 2 standard deviations, so on and so forth. And we're going to use it specifically with independent t-test. And we get the answer after plugging in this formula, and then we compare that answer to the Cohen standard effect sizes. So small would be 0.2, medium 0.5, and large is 0.8. So that's how we're going to interpret Cohen's d when we get that from plug into the formula. We're going to interpret using this scale. So here are the two equations that we use. This is a breakdown on which each of the variables are going to mean. And you just plug in this formula first to get the pool standard deviations for the two groups. And then you're going to plug it into this formula here. And D is going to be Cohen's d. So here is a practice problem for you guys to pause this video to try it on your own. And if you completed the problem, you would see that we would end up with 0.84, which when you refer back to the size of effect, this is going to fall under the large category. So this is going to mean that the effect size of the specific problem would be large. And that is going to be how you interpret Cohen's d. So it's a very simple formula used for t-test, which is more on the simpler side of statistics for testing. And that's going to be how you get that effect size. Now we're going to go to partial eta squared. So this is defined as the ratio of variance accounted for by an effect and that effect plus its associated error variance. And it's going to be specifically within a Novus test. So this here is the equation, and it's basically what I said in the definition. It's going to be the sum of squares for effective interest over the sum of squares for effective interest plus the sum of squares for whatever error is going to be associated with that effect. Like I said, it's going to be used in ANOVA design, typically in non-independent cells when a person appears in more than one cell. And the results we're going to show as a percentage of the variance in each effect or interaction. So we're going to report it as a percentage. And this here is the scale that we're going to use. I got this from Dr. Mullen. So small, less than 0.01. We have the medium, large, then very large, 0.168 to 0.360. They do vary pretty heavily in the research, but this is the one that Dr. Mullen recommended for me. And this link here is just to walk you step by step on how to plug in partial eta squared in SPSS. So we're going to go into an example problem. So when you plug it into SPSS, this is what we are going to get as an end result to be able to interpret. So step 1, we want to determine the statistical significance. And as you can see here, each of these are going to be statistically significant. Then we're going to interpret the effect size. So the effect size of employment, as you see here, is twice as strong as health. Employment alone is 0.095 for effect size. Health alone is 0.048. And then right here, or when we look at them both, 8% of happiness is contributed to the interaction of employment. That's how you would write it out as a percentage. And here is, in conclusion, just for your reference, I broke it down side by side on how to interpret both. So the big points are going to be the definition is going to be different. Cohen's d is going to report it as a strength, while partial eta is going to report as a percentage. We're going to use Cohen's d for t-test while we use partial eta for ANOVAs. And then of course the scales are going to be different as well as those formulas. So thank you. Hopefully this helped out.